Hey Techno Studs! There's several technologies that help facilitate these WAN connections. So let's talk about a few of the technologies you would see out there. I'm going to run through several of the technologies that you would see out there, such as fiber, T1s, ISDNs, DSL. So we're going to just run through these technologies. I'm going to make just a few mentions about some highlights of each of these technologies. First up, we have fiber. Fiber is one of those technologies that's pretty prevalent out there because we can go long distances and the signal doesn't degrade with those long distances as much as some of the other technologies. So fiber is a great option for long hauls or even sometimes between your equipment for these fast speeds. So with fiber, there is a couple terminologies you should be familiar with. Now, fiber could be something that you have installed and you actually own the fiber, or it could be something that you use a service provider and they lease you lines and you just are leasing these lines. So some of the terminology you should be familiar with is you might have fiber to the and then whatever. So for instance, fiber to the home, which would be fiber to FTTH, or you could have fiber to the building, which would be FTTB, or you could have fiber to the neighborhood or fiber to the node, which would be FTTN. So there's some different terminologies and it's just where is it going to? Where is it ending up at? Now there are several technologies that help facilitate communication across fiber. To mention a couple, we have SDH, which is synchronous digital hierarchy. So that's one of them, and that's a global standard. Or here in the US, we have SONET, which is synchronous optical network. So that's a North America standard. And then one other thing to mention about fiber is also, I went really in depth into multiplexing, but we're able to carry several signals across it using different types of wavelengths or different methods to get multiple signals across this. So we can actually multiplex or have several signals going across this fiber at one time. Then we have T1s and E1s and T3s and E3s. The T and E, T is for a North America standard, and an E is a Europe standard. So if you see T, think North America, E is Europe. And the T has speeds of or the T1 specifically has speeds of 1.544 megabits per second. And an E carrier has a 2.048. So there's a little difference in the speeds of those. If you're looking at a T3 or E3, a T3 has a 43.7 and an E3 has a 34.368. So those are just some speeds. We don't really see the T1s and E1s as prevalent anymore. This is an older legacy standard, and a lot of these type of connections doesn't have enough bandwidth to support a lot of the usage that we have nowadays. Then we have the public switch telephone network, the PSTN or public switch telephone network. Think dial-up with this. Yes, dial-up is still used, and that's because a lot of the older homes don't have fiber connections, don't have cable connections that are running to them. And so if you're too far away from a central office, then you might not be able to have connectivity with something like a DSL connection. And so dial-up still is an option for some users that are out there. So wherever your home is, they would come back to a central office, and that central office then would have some connectivity where you'd actually connect to the internet. Because of the bandwidth of the capabilities of this, you're only at 56 kilobits per second. So it would be pretty slow in nowadays standards. So it's not an ideal setup, but it is still out there and you still could see this out there. So if the only thing that was available to you is a public switch telephone network, and dial-up was just too slow, one thing that might give you a little more speed, and really the advantage of this one is also it carries both data and voice, and that is an ISDN connection. An ISDN connection is an integrated service digital network. And so the ISDN connection, once again, can carry more than one signal, which allows us to get a little more speed out of it and carry a voice at the same time. So that is one option. But this would be something that would be very expensive back in the day. Once again, this is the legacy, so you don't see this quite as much out there. But if you didn't, if you wanted faster speeds and probably a business because ISDN connections were a little more expensive, then you could go down this route. If the only option coming into your home is these telephone lines, is this public switch telephone network, another option for you would be DSL. Possibly an option for you. And I say possibly because if your home's right here and you're going into a central office, it's connecting into a central office, to get DSL, and DSL has much faster speeds, so it can carry a lot more data across it. There's a couple different types. There's ADSL or asynchronous DSL, and there is a symmetric DSL or SDSL. DSL stands for Digital Subscriber Line. So when your home makes a connection into the central office, these are the telephone lines that are going into it. Your central office needs to have what's called a DSLAM in it, or a DSL access multiplexer. So the DSLAM is a piece of equipment that kind of aggregates a lot of these DSL connections and then gets it onto your internet service provider. And onto the internet. So with this, your central office, the one that you're connected into, has to have one of these DSLAMs, and not all central offices do. And then the other thing that's the problematic with this is that your phone line has to be a clean phone line. And what I mean by that is your phone lines, you need to be close enough. The distance makes a difference. Also, some of these cables continue to go down and spread out and have crosstalk, and so you could have this really long cable and just a piece of it gets terminated at your house, and that can be problematic as well. So it needs to you need to have a clean DSL line. You need to be close enough within like 3 miles of your central office to have a good connection to get DSL services. So therefore, that's one of the reasons why it's a little limited on whether you can get DSL connectivity. It definitely gives you higher speed. I've had good luck with DSL connections in the past. And so, and it's a little different than cable. A lot of people like to go with cable, which you're part of a hub in your neighborhood. So if that hub is saturated, it can slow you down. Where DSL actually has a direct connection into the central office just for you, so it can be a really solid connection, and hopefully there can still be saturation if they've oversubscribed how many subscribers are on the central office, but you don't have some of the same issues that you have with cable. That being said, cable tends to be the preferred because it tends to be faster, and there can be some latency issues with DSL. Then we have frame relay. Frame relay is an older legacy technology as well. You would connect into your internet service provider. So you would have an internet service provider. They would have some sort of router that's connected into there. And then they have a network, a layer 2 network of these frame relay switches. And what they would do is they would define a route for you to travel to get to make a connection from one point to another. And then, so it's a layer 2 technology, so it's a little bit faster and gets the data from one point to another, and then you would be guaranteed some sort of transmission rates along there. Frame relay is considered a non-broadcast multi-access network. It's non-broadcast because it's sending it directly to, it's getting switched directly to this different equipment. It has a series of interconnected LANs, as you can see, that I have here, that sets up what's called a private virtual circuit. So this would be a virtual circuit here that you are, essentially it's carving out a certain section of the line that's guaranteed to you. And then each of these lines have certain identifiers, or what it's called a DLC or DLCI, a data link connection identifier. And these DLCs are numbers that identify a circuit that that would be assigned to you essentially. So that's a little bit about frame relay. Frame relay is one of those things that you would subscribe to, and then you would have a connection between your sites. Then we have ATM. ATM is asynchronous transferred mode. ATM also is a legacy technology. You don't see it as much anymore. But the key difference with ATM is how it does its multiplexing, how it uses shared lines but still guarantees you that you have a certain bandwidth between connections. So if you've got a couple connections, I'm just going to put it in like this, where there's a connection between these 2 points. And what it does is it sends 53 bytes at a time. So each frame that it sends across it is 53 bytes. And then this would be the channel A, this would be channel B, this would be channel C. So there'd be multiple channels in here, and you would be guaranteed one of these channels. So a channel would be essentially subscribed to you, and you would have that 53 bytes. And then, then at a certain point, then channel A repeats itself. And so it blocks off the communication for that period of time for channel A, and then for a period of time, channel P. And it's really fast. Only 53 bytes go across it at any given time. So that would be ATM, or asynchronous transfer mode, ATM. Then we have cable. So to our homes, we've already talked about fiber to the home, which is a much newer technology and becoming more and more common. We have phone lines to the home, which we talked about how they're really meant for voice and can cause some problems and be slow. So DSL is a good option for that. But one thing that can be a lot faster is cable. So this is the gamers like cable because of the speeds that it offers. And so cable can be a great option, can be a cheap option to get data to the home. And we've had cable going to the homes for quite some time now just to deliver cable TV to us. So a lot of homes have this capability nowadays, and then you can get data across this cable line now. It uses something called Data Over Cable Service Interface Specification. So that's a big word, but it's DOCSIS is what the acronym is. So this DOCSIS is Data Over Cable Service Interface Specification. It's an international standard, and that's what they use to get data across to the homes. One of the disadvantages to the cable is that your homes connect into a hub, and that hub can get saturated at times. This used to be a big problem in the past. I feel like that they're getting better with this, and it's not as much of an issue nowadays. But a lot of times you would see slowdowns during certain times of the day because this hub, this neighborhood's hub, would get saturated if everybody was going home and watching or gaming, watching movies or gaming. Then it could cause problems within your neighborhood if it was oversaturated. So that's cable, a great option nowadays. They keep getting it to go faster and faster, and I've certainly switched from DSL, which I was pretty happy with, over to cable, and now cable seems to be a great way to go. All right, that was just a pretty brief highlight of all these technologies. We talked about fiber, T1s, PSTNs, or the public switch telephone network, and how that we could use dial-up on that. We talked about ISDN over those PSTN connections, or DSL over those PSTN connections. We talked about frame relay, ATM, and MPLS as a connection that you could subscribe to get your businesses connected, and cable connection, which is a very common, one of the more popular ones that are out there nowadays.